Okay, so we got this problem here. Oh, let's make this. No, it's fine. And you want to get it into a factored form. So first we start by looking at the graph and finding something we can factor out of this. So I see the graph here. It looks like I got those two real roots. So I got 1. So I'm going to do, that means I can factor out x minus 1. So I'll set up my PolyDoku here. I was just draw a bunch of squares and I don't know how many I'll use. That's probably enough, right? And let's do, yeah, let's just do it this way. Okay. Cool. So I got, shade that one in. X to the 5th, that always goes to the top spot here. I'll go ahead and write all this out here. Plus 4th plus 12 x cubed plus x squared minus 12 x minus 12. Okay. This first term always goes right here. Cool. Because the graph goes through x equals 1, that means that x minus 1 is a factor. And that's where, what are you doing? That's where that comes from. So x minus 1. Okay, so let's just do the PolyDoku process. X to the 4th times -1 is negative x to the 4th. Okay, so I got 6 down here, got -1 right here. That means I need 7x to the 4th to get to 6x to the 4th. So therefore, this is 7x cubed. This is negative 7x cubed. Let's see, I got 12 of these down here. I got negative 7 here. So that means I need 19 positive ones to get up to that. So we're going to get some big numbers here. Let's see, this will be 19x squared. That'll be negative 19x squared. Up to 5, that means you need 26x. Oh, sorry, wrong spot. 26x, geez, 26x squared, which combines with negative 19 to give you 5. Wait a minute, that isn't right. Let's check that. Gotta cut that. So negative 19 plus 19 gives you 0, and then add another 5 to get that. So it'd be 24. Oof. Makes 24x. There we go. So 24 minus 19 gives us 5. Okay. That would be negative 24x right there. And then I got negative 24x to 12x, to negative 12x. That means I need to add 12 more x's. Gives me a 12 there, and negative 12 there. Those two match up. Good deal. So just to check, what that means is I've rewritten this to be x minus 1 times all of this right here. X to the 4th plus 7x cubed plus 19x squared plus 24x plus 12. Ooh. Okay. So now I'm going to continue to factor. Now I'm just going to factor this part. Let's look back at the graph and see something else we can factor out. Okay, goes through -2, which means I can factor out x plus 2. So that's what I'm going to do. So let's just continue this over here. Now this is the tricky part. This new polynomial that I've gotten from the last one, it's what goes down here. Below. Because we don't want to factor the original because we've already factored out x minus 1. So now I'll just draw another box in here. Again, I don't care how many, I just put a couple. And if I need them, I'll need them. Let's see. So I'm now factoring out x plus 2 because the graph goes through -2. Okay, and then let's see. This first one always goes right here. Okay, so this will be x cubed, 2x cubed. I got 2, I need to get to 7. That means I need to add 5x cubed. So that's just 5x squared. That's 10x squared. I got 19, so I need to add another 9x squares. That'll be 9x, 18x. And if you're still struggling with this process, you definitely need to ask or check it out. Like, again, keep in mind how these things must combine in diagonals to equal the terms down here. 2x cubed plus 5x cubed gives you 7x cubed. 9 and 10 make 19. I got 18 x's here. I need 24 total, so I need to add another 6 x's. Those combine to give me 24x. This will be 6 up here, and that'll be 12. Good deal. Those match up. All right, so that means I've now rewritten this one to be x plus 2 times x cubed plus 5x squared plus 9x plus 6. And that came from That's this right here, came down here. And then to put it all back together, I had already factored out x minus 1, so it's still up front. So this is my full polynomial. Let's just check that real quick. The original one I started with, degree 5. So at any moment, my full polynomial still should be degree 5. Like right here, well, this would be x times x to the 4th, degree 5. Down here, there's 1 factor, there's 2, and then another 3, so this is still degree 5. Good deal. This right here could be factored. Now this is a little tricky. Go back to the graph. I've factored out all of the linear roots, except it bounces right here. But so think about when you have a bounce in a graph, that means it should be x plus 2 squared, right? So therefore, there's another x plus 2 that I can factor out. Meaning, I should have x minus 1, x plus 2, another x plus 2, and then some quadratic that'll go there. So let's do that. Let's factor out x cubed plus 5x squared plus 9x plus 6. Okay. Same thing before. Okay, I'm going to shade that one out. So I'm factoring out another x plus 2. And this is x cubed. Okay, this one will go a lot quicker. So x squared, 2x squared. So I need a 3x squared here. That's 3x, so that's 6x. I need another 3x here. So that's a 3 and that's a 6. Good deal. So now I've got x minus 1, x plus 2, times another x plus 2, times x squared plus 3x plus 3. Now, can this last one be factored? Let's see. Two things that multiply to be 3 would be 1 and 3, but could you add 1 and 3 somehow to get 3? No. So that right there is not factorable. And you could do box and diamond if you want. That's kind of what I just did audibly. Okay, so that means I'm done factoring, and that is factored form. Okay. Now, when it says, don't you need the roots? Well, that's pretty easy for the most part. We've already got x equals 1. We already found that. We've got x equals negative 2. We found that. What about this guy, though? They could be non-real. They could be just irrational. They could be decimal, something like that. So we have to do the quadratic formula to figure that out. So let's do that. So x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. Negative 3 plus or minus, let's see, that's going to be 9 minus 12. That's a negative 3. So there's that means the discriminant is a negative. So we'll have 2 non-real roots. All over 2. And you know what? Actually, we're pretty much done. We can't do much else with the square root of 3. We can't simplify that. So all of my x's together are 1, negative 2, and negative 3 plus or minus I squared of 3 all over 2. Those are all the roots. Now, this was a degree 5, so we could have had 5 roots or fewer. And recall, because this one was a double root, it kind of counts as 2 for the sake of the degree. So we got 2 non-real, 2 non-real, 2 real, but one of the reals is a double, which is why we have a degree 5 total. Okay? So, and how we could check our answer, that's a lot of work right there. How we could check our answer would be just to graph the original problem, which was the x to the 5th and stuff, and then graph the factored form, or your answer, and they should be the same. Should be the same. Lots going on here, lots of little things that you can make errors. So please try to check your work as you go. And that's how we do it. That's all the process.